Hey guys, this is Mr. Grice for Algebra 2 with Ms. Carranza and myself. Uh, we are going to be talking about Algebra 2, Section 1.2, Part 1. For this, you will need a separate sheet of paper. So if you do not have one out yet, please pause the video and grab one. Okay, so today we are going to be talking about simplifying and evaluating exponential expressions. Okay, so the only thing that's different than some of the other stuff that we've been talking about is that we are going to be talking about uh, exponents today. Okay, all right. Now, here is an example of an exponential expression. If you notice that it has three parts. Okay. Now, the first part that we're going to talk about is called the base. The base is the number that is right underneath the exponent. Okay, and the definition says it's a number or variable that has an exponent. So that is the exponent, which is our next one. The 5, that little guy, represents how many times a base is multiplied by, with itself. So the 5 is telling me exactly how many x's we have. Now, the next one is the coefficient. And the coefficient is the 2. And the 2 is, that coefficient is a number multiplied in front of a variable. Now, we have a little note that's right next underneath that says, this expression above is not equal to 2x to the 5th. Now, the reason that is let's go through the two different ones. 2x to the 5th, we said that x is the base. So this is saying my coefficient times my base. And the exponent tells us how many bases there are. Now, in 2x with the parentheses to the 5th, my base is 2x. So it's saying 2x times 2x times 2x times 2x. Okay? Do you kind of see the difference there? All right. Let's move on to some different notations. Now, when you see the expanded form, one of the things that we're going to tell you is mathematicians are very lazy. They don't like always writing all these things out. An exponential form in exponents was actually created by scientists who were writing distances to faraway places, like, say, to Saturn and back, where they would do these equations and they had these really long answers. And that's pretty long to be writing just a whole page just full of numbers. So that's where these exponents came from. So when you see 8, the 8's like that, 8 times 8 times 8 times 8. Another way of saying that would be 8 to the 5th. Okay. Same thing here. We have 1, 2, 3. 3 over 2's, and that's how we would write it. Same thing with decimals. 0.3 times 0.3 times 0.3 times 0.3 gives us 0.3 to the 4th. Okay. Now, evaluating the expressions. Okay. Now, we know that 3 squared, 3 is my base. It means 3 times 3. Hopefully that one's not too difficult, where 3 times 3 is 9. Now, some of these you might need a multiplication chart. Okay. Now, 5 to the 4th. 1, 2, 3, 4. And I'm going to break these down. 5 times 5 is 25. Multiply those two together and you get 625. That's actually the last one on your multiplication chart. Okay, number 3, 8 to the third. 8 times 8 times 8. If you break this down, 8 times 8 is 64. And if you do not know what 64 times 8 is, I would just do that to the side and do it the old school way. 8 times 4 is 32. 8 times 6 is 48, plus 3 is 512. Okay, now let's do number 4 real quick, because 4, right away when we see this 1 to the 4th, our brain wants to say, hey, the answer's 4. But that's not right, because 1 to the 4th is saying 1 times 1 times 1 times 1. And 1 times itself, no matter how many times is 1, you could say 1 to 326, and the answer is 1. Okay? Now, for numbers, let's go to 6. 6 is saying 12 to the first power. Okay? 12 to the first power is just 12. Because remember, the exponent is telling us how many times to multiply 12 by itself. And it's saying that there's only 1. Okay? Now, let's take a look at number 9. And number 9 is the same thing as 7 and 8, but 1 to the 5th, or 1/2 to the 5th power. Now, what we can do with rules of exponents is we can distribute the 5. Okay? 1 to the 5th is 1, and 2 times 2 times 2 times 2 times 2 will give us 32. That one you can do in your head. Okay? Now, if we were to write the expanded form of that, it would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. 1 times 1 times 1 times 1 times 1 gives us 1. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 gives us 32. All right. Now, evaluating exponential expressions with decimals. Now, there is no shortcut to this. You will have to do this part by hand. So, what we're going to do is practice it. 0.5 times 0.5. We're going to line them up like we normally would for multiplication. And now we multiply. 5 times 5 is 25, and 5 times 0 is 0, plus 2 is 25. Okay, add the 0. 0 times 0 is 0 times 5, and then 0 times 0. Now, the only question is, where does the decimal go? So what you need to do is count how many numbers are behind the decimal. So let's count. I have 1, 2. 2 numbers behind the decimal means I have to go 1, 2, and our answer is 0.25. Okay? Let's do that again with number 11. Okay? It's 7.4 times 7.4. Let's multiply these out. 4 times 4 gives us 16. 4 times 7 is 28, plus 1 is 29. We're going to add the 0. 7 times 4 is 28. Carry the 2. 7 times 7 is 49, plus 1 is 51. Let's add all that up. Now, where does the decimal go? Let's count. We have 1, 2 numbers behind the decimal. So we put the decimal 2 numbers in. Okay? Now, that's going to be it for evaluating exponential expressions. If you haven't done the homework yet, it is right here in your book. And as always, if you ever need extra help, please come see Miss Carranza or myself. All right? Thanks, guys.